Using differences or ratios to identify functions. Okay, so got some t-shirts here, and it could be horizontal or vertical. If you have constant first differences, meaning you add the same number here, it would be a linear function. If you multiply by the same number, it would be a common ratio. And if the second differences are constant, it's going to be quadratic. So let me show you what I mean. And we've done this before. All right, on this side, to get from -3 to -1, I'm adding 1, I'm adding 1, I'm adding 1, and I'm adding 1. Over here, to get from 11 to 8, I'm subtracting 3. And to get from 8 to 5, subtract 3, subtract 3, subtract 3. So you see this -3, that is a common difference. And if I've got a common difference, it's a first common difference, then this one would be linear because the common difference is a -3. All right, so looking at this one, I could go up 1, up 2, up 4, and up 8. Well, that's not the same number. But think of this. How do you get from 1 to 2? Well, there's also the option of multiply by 2. Times 2, times 2, times 2, times 2. So if it's multiplying by the same number, multiplying by 2, then this thing would be exponential, because that is a common ratio. All right, now look at this one. To get from -1 to -2, I have to add a -1 to it. And to get from -2 to -1, I'd have to add 1. And to get from -1 to 2, let's see, I'd have to add 3. And to get from 2 to 7, I'd have to add 5. That's not the same number, so it's not going to be linear. And then these right here would be called the first differences. Now, always go back and check this. Well, what would you do? How would you get from -1 to 1? Well, that would be to add 2. And how would you get from 1 to 3? Add 2. And from 3 to 5? Add 2. So these right here would be called the second differences. And I want you to notice that the second differences are the same thing. They're constant. So if that's the case, the second differences lets me know that this is a quadratic formula.